Hello friends and welcome to edupediaworld.com, your destination to online education. Friends, today I'm going to start with a new topic which is called isotopes. To make you more clear about this topic, I have subdivided this topic into 5 sections. First is the isotope. We'll cover the concept and the meaning of isotope. Second, types of isotopes. Third, examples of isotopes. Fourth, properties of isotopes. And last is the uses of isotope. So friends, what do you mean by isotopes? Is it same photograph with a different frame structure? No. Or same material ball with all same design but different size and mass? Is it? Are you still confused? Okay. Let me give you more daily examples which will make you more clear about isotopes. So friends, if I take an example of a basket, two identical baskets with all same design, color, frame, circumference, area, everything is just identical to each other. So each basket is having balls in it. Let first basket A, and this is basket B, both having two red balls, three blue balls, here also three blue balls, and basket A is containing one green ball, and here it is having three green balls. So first of all, let me tell you the similarity they have. What is the similarity between them? First of all, they are identical. Second, they have same number of red balls and blue balls, right? So what is the difference between them? Difference is they have different number of green balls, right? So therefore the mass, or you can call it weight, of the bucket is different, right? So here you can see both having the identical shape and size of this bucket. Then they contain the same number of red and blue balls. They only differ in the green balls. That is, the difference is the weight. If we carry, it will be more heavier, and this will be the lighter one, right? So similarly, if I talk about in the terms of chemistry, we have elements. When we talk about chemistry, we talk about elements. Every element is made up of atom. We know that there is a center of atom called nucleus with a proton and neutron. Then there is a orbit where the electron revolves itself around the fixed path. So this is a structure of an atom of an element. If an element in the nature have the same structure, same atom, but with different number of neutron present in the nuclei, right? So what you call these elements? They are just identical to each other, as it is noticed that two atoms of the same element contain same number of protons but differ in the number of neutrons. So electron, proton and neutron are basically arranged in the same way and give the atom identical chemical properties. So first of all, I give you a important note here that the atomic number of an element never changes. That is, the number of proton never changes itself, but the atomic mass is changed if the number of neutron present in an atom of the element is changed, or you can say is different, right? So what we call these elements, we call them isotopes, right? So friends, here there's a one more important note that the isotopes was discovered by Sir J. Thomson with their assistants and the study of the isotopes is isotopy, that is element which shows the characteristics of isotopes are isotopy. So in the conclusion, if I define the isotope, what will I get the definition? So we say isotopes are atom of the same element having the same atomic number but different atomic mass, as the number of neutron goes changing. If I give you an example of chlorine, so chlorine where the atomic number of chlorine is 17 as the number of protons present in the atom is 17, which is fixed, will not change. The atomic mass is the number of proton plus number of neutron, where number of proton is 17 and number of neutron is 18, which comes out 35. So at the end we write Cl. This is the symbol of chlorine. Here we write the atomic mass and here we write the atomic number. And the chlorine have one isotope, that one similar element with a different number of neutron, which is having N as 20. So what is the new atomic mass of its isotope is 17 plus 20, that is 37. So the symbol will be Cl. Here we write 37 and here 17. So what are the two isotopes we have? One, which is a normal element, and this is the isotope of the chlorine, right? So friends, I hope now you got a blink of the picture of isotope. So now let's understand the types of isotopes. There are many different kind of isotopes which have the number of neutrons in the very large scale, and one they have a very minimum neutron in the nuclei of the atom. But let me first give the concept of the types of isotopes. For example, there is a balloon. This is a normal balloon with a normal air within it. And this is a much larger balloon than the normal balloon. And here we have the largest of the balloon, which have the extraordinary air in it. If you can see the size, you can also imagine the heavier of this balloon, which is the third one. We call it C balloon. Let's name them A, B, C. This is the normal balloon. And this is quite the medium balloon. And this is the heavier, right? Similarly, if we talk about in terms of isotopes, we have a normal element which behave in the atmosphere very normally, react very normally, have the very normal chemical and physical properties, which have the very normal number of neutron with them. And one, we have a medium element, that is the isotope of that particular element, right? And one, there's a heavier isotope having large number of neutron in the nuclei. If we talk about the medium elements or isotopes, they're basically very slow reactive, that is having a very slow reaction. Here, as a large number of neutrons in the nuclei, there is a very large number of energy which comes in terms of radiation, just due to the large number of neutrons. So this happens to make them decay very rapidly. So now we talk about the types. We have two types of isotopes. One is a stable and one is a radioactive isotope. So what do you mean by stable and radioactive isotope? Yes, stable are the very medium, the medium or say stable isotope of the element. They basically react very slowly. They don't decay rapidly. Why? Because they don't have any uh, lots of energy in the nuclei of the atom, as the number of neutron is very much similar to the number of proton. So the radiation does not form in that stable isotope. If we give the contrast with the radioactive, they are the most reactive isotopes, and they are the heavier one. Third, they decay rapidly. Fourth, they have huge amount of energy in the nuclei, which they pass in terms of radiation with the alpha, beta, gamma rays, right? So this is the basically difference between the stable and radioactive. As I told you, the example of balloon, the heavier balloon have more tendency to burst, give all the energy, all the air outside the balloon area, a wall of the balloon. So now let me give you the brief. So this is a stable isotope and radioactive isotope. It is a normal isotope which differs in the number of neutron in their nuclei with respect to the stable element. They are the lighter isotopes and they react very slowly. In radioactive isotope, if we compare with the stable isotope, they are the most unstable isotope as they have very high level of energy in their nuclei. They are the heavier and emit energy in the form of radiation. They react very quickly and undergo various radioactive decays. So friends, I hope you have understood now the types of isotopes. So let me give you some examples and make you the topic of isotope more clear. Let me give you one example, one good example of hydrogen. Hydrogen is the very lightest element of the nature with the one proton within it. Hydrogen basically have three isotopes. One is called protium with atomic mass 1. Second is deuterium with the atomic mass 2. Third is the tritium with the atomic mass 3. So let me give you a diagrammatic view to make you more clear. One proton with no neutron in the nuclei. This is the protium. One electron, one proton. In second, there is a one proton and one neutron. With the electron in its orbit. It's the deuterium. Third, with the one proton and two neutron in the nuclei of the atom, of hydrogen atom, an electron which is revolving in its orbit. It is the tritium. Let me label it. Protium, deuterium, and tritium, right? So friends, let me give a table view for this. Let's give a complete composition of these three isotopes of hydrogen atom. Isotopes. Here is number of protons, neutron, and electron, right? This is the protium, symbolized by this. This is deuterium, symbolized by this. And third is the tritium, symbolized by this. So number of proton in protium is 1, 0 neutron, and 1 electron. In deuterium, it's 1 proton, 1 neutron, and 1 electron. In tritium, there is a 1 proton, 2 neutron, and 1 electron. In these three, this is the heavier one. This is the heavier isotope, and we call this is the medium. We call them stable isotope. Right? So this is the example which I gave you for the isotope, the hydrogen isotope, having three isotopes. Just learn by heart the protium, deuterium, and tritium. It will be more useful for you for the competitive exams. So friends, let's take a view of the examples. So here is the carbon atom, carbon element with the 12 atomic mass. 6 is the atomic number. We have two isotopes here. We call it C12 and C14. C14 is the radioactive isotope, which is actually used in the some archaeological and medical sciences research projects, where the number of neutron is differing from the number of neutron in the C12. Here it is 8 neutron, here it's a 6 neutron. Let me give you one more example. This is the example which I have just described you in the rough note. There are 3 isotopes of the hydrogen atom: protium, deuterium and tritium. This is the diagrammatic view of the example. And let me give you one more example which I have give you in the first rough note in the first section, which is the isotope concept. These are the 2 isotopes of chlorine with C35 and C37, Cl37. They have the identical electronic configuration. Just because the number of electrons and protons are similar, so they show identical chemical properties. Similarly, all the 3 isotopes of hydrogen, H1, 2H, 3H, have identical chemical properties, but they all have different number of atomic masses. So here, friends, I hope you have understood the examples also. So let's go to the main menu to get the properties. So what are the properties of the isotopes? How do they react? Let me give you a brief view. First, let me write the properties. Properties of isotopes. Friends, first and very important property of isotopes is, since all the isotopes of an element have identical electronic configuration containing same number of valence electron, therefore all isotopes of an element show identical chemical properties. So this is the very important in the competitive point of view also, and your academic exams also. They have the identical chemical properties, right? What is the reason behind this? Reason is just because they have same number of electrons, therefore same electronic configuration, right? As the chemical properties depends upon the number of electrons only and the electronic configuration, so they have the identical chemical properties. If I give you an example of the carbon, this is the C12 and C14, both have the same number of 6 electrons in them, 6 electrons, right? And both of them have the identical electronic configuration, which is 2 4. Let's write here the electronic configuration, which is 2 4, both. So by this Both the isotopes of carbon C12 and C14 have identical electronic configuration having same number of 4 valence electron, so they show identical chemical properties. Similarly, the isotopes of hydrogen have the identical chemical properties. Reason behind this is having a same electronic configuration as the valence electrons are same. So friends, what is the second property of the isotope? Can you guess this? It is as the physical properties are different, right? Why? As the physical constant, that is physical properties, depends on the atomic mass, and the isotopes have different mass number, that is they have the different numbers of neutron with them. Thus the physical properties of isotopes of an element are different. So let me give you the reason behind this. Is what is the reason for this? They have different number of neutron in their atom as the physical property of element or isotopes depends upon the atomic mass, right? So here is the reason behind the difference in physical properties, that the number of the neutrons in their atom is different. So the physical properties are different. Third, if I count, is that the atomic mass of an element have a fractional atomic masses, that is they have fractional atomic mass. So let me describe you by this, as the atomic mass of many elements are in a fraction and not in a whole number. For example, atomic mass of chlorine is 35.5, whereas copper is 63.5. Why? As the fractional atomic masses of element are due to the existence of their isotope having different masses. Yes? So the most of the element have more than one isotope having different masses. Since the atomic number of the element is the average relative mass of all the neutral isotopes of that element, which most of element have the fractional atomic masses. I think this is making you more puzzled. So let me give you a good daily example to give you a proper view on it. For example, if you see there is a fruit basket with many red apples. There's a many red apples in that basket. Basically, when we talk about the fractional atomic mass, we actually looking for the abundance of the particular isotope or particular element in the nature. What is the abundance presence of that element in the nature? And when we talk about the isotope, we average out the abundance of that particular element and give the weighted average of that particular element and give a fractional atomic mass. So here is the abundance of the red apple in this basket. And if we talk about the green apple in that particular basket, the abundance is very less. Though it is actually present in the nature, we have to take this the presence of this green apple in the count. So if I talk about the abundance, let's suppose green apple is 25% of green apple, and if I talk about the abundance of red apple, which is 75% of red apple. If I talk about the cost of red apple is 50 rupees, and if we talk about the green apple, it's 100. So if I take the average of the price, what comes out 100 by 2 is 150 by 2, that is 75, which is actually not right because the abundance of this particular both of the apples is different. Now if we take the weighted average of this, which is, if we talk about this, is 25 into 100 plus 75 into 50, what is the result? 2500 plus, so what is the result? This is 12,600. Now if I give the weighted average, what comes out to be 1, 2, 5, and if I give the percentage, it comes out 31.25, right? So here is the weighted average of the apple, which is the abundance of the apples, varieties of apples in the nature. So now, if I, in terms of chemistry, let's take an example of chlorine, 35Cl, 17 and 37, 17Cl. So these are the isotopes of the chlorine element. So how do we get the weighted average? Let's suppose the abundance of the Cl35 is 75%, 0.5%, and here it's 24.5%. So if we talk about the mass of 100 chlorine atom, what will you get? 75.5 into 35 plus 24.45 into 37, which comes out to be 3549. So what I get the weighted average, that is the average atomic mass of chlorine, as we are taking the atomic mass of an element representing the weighted average of all the naturally occurring isotopes of that element. This is, you have to keep in mind. We are taking the abundance of that particular element. So the atomic mass comes out to be 35.49, or say 35.5. So this is the fractional atomic mass which we calculate in terms of weighted average. So friends, let's conclude the properties. So the chemical properties of all the isotopes of a particular element are same, as the number of valence electrons and the electronic configuration of that particular element and their isotopes have same. And the physical properties or constants of isotopes of element are different. Reason behind is the number of neutron present in the nuclei of that atom of the isotopes are different, as the physical properties depends upon the atomic mass of the element. And third, the fractional atomic mass of an element are due to the existence of their isotopes having different masses. So friends, here I have completed 4 sections. Fifth is the uses of the isotopes. What are the uses nowadays we have in each and every sector? The isotopes are being used. Basically, the radioactive isotopes are more useful than the stable isotopes, as some isotopes are radioactive and used for treating cancer and other diseases. Carbon-14 is used for determining the age of historical and geological materials. Third, the isotopes of hydrogen, oxygen, nitrogen, and carbon are employed for studying the nature of the organic reactions. The isotopes are also used in killing many bacteria from food and make the food safer to eat. I have give some examples. You can get more examples from newsletters, magazines, your textbooks, and you can also view many websites. You can get more uses of these isotopes. For your exam point of view, these 4 uses you can write and get a good marks. So friends, by this I'm ending up this session. I hope you have gone through the whole session and got a good idea about the isotope. So I'm not giving a big activity for you now. You have just need to write the answer of this question, which will give you a whole idea of the isotope. That is, what are isotopes? Explain by giving at least 2 examples. You can write this answer in your notebook, any slate paper. Thank you. So friends, in next session we are going to meet with the topic chemical activities versus atom. I just want to make you learn about what are the relations between the chemical activities of an atom, what they do, why there is a combination of element making and compound, how these chemical reaction, the bondings, the ionic bondings, the covalent bondings are formed. So friends, let's meet in the next session. Thank you.